All right, welcome. In this video, I'm going to be working through the Pre-AP Algebra 2 practice semester exam. And we worked this in class. This was just for your benefit. This wasn't a grade or anything. And I've already posted the answers, but in this video, I'm going to be going through and explaining why, each answer is what it is. So I'm going to start off, I'm just going to go through in order. So I'm just going to start with 101. Which of the following lines is perpendicular to the line y equals negative 3x plus 2 and passes through the point negative 2, 8? Okay, so what I think I'm going to remind you of is that perpendicular lines, their slopes multiply to -1, or their slopes are opposite reciprocals, however you want to say it. So if my first line has slope -3, then a perpendicular slope would be, that'll be -1 over -3. So that's just going to be positive 1/3. So I'm looking for a line that has slope 1/3. That's not f and not j, because if I wanted to find the slope of j, I would divide both sides of that equation by 5, and I'd see it was, I think, 3/5. So I'm down to g and h. And so I guess that's where -2/8 is going to come in. So probably I'm going to say, okay, I feel like it's probably going to be h, because I can see it's going to work out with arithmetic. Just whichever one you think it is, just plug in -2/8 and see if it works. So is 8 equal to 1/3 of -2 plus 26 over 3. Well, that would be -2/3 plus 26/3 equaling 8 is 24/3. That is true, so I know it's going to be answer choice H. Okay. Number 2, which situation is best represented by the function f of x, where f is 12x plus 5? Okay, so this is a linear model. It's got like kind of a starting value of 5, and then it's got a rate of change of 12. So I'm looking for, 12 each. If I'm seeing a lot of each in the answer choices. The only one I'm seeing with 12 each is going to be D. Yeah, $5 starting value, so that's like, the flat rate shipping fee, plus $12 for each baseball cap. So that's going to be D. Okay. So just to emphasize once again, the y-intercept of a linear model, that represents the starting value, and the slope is going to be the rate of change, or how much each thing is worth in some sense of worth. In this case, it was money. Okay. Now we're going to write an equation for D. Write an equation for each line. Okay. So a horizontal line. If you remember, the horizontal lines have an equation y equals some number, then good for you. You'll be able to do this one pretty quick. But if not, just kind of plot a few points and be like, hey, what do all these points have in common? They all have the same y-coordinate. Their y-coordinate is 3. 0, 3, 1, 3, 2, 3. This is the line y equals 3. Then we can do the same thing over here. If we remember that vertical lines have an equation x equals, then that's great. But if not, we can just kind of plot some points and say, okay, what is common to all these points? Well, they all have the same x-coordinate. They all have x-coordinate equal to 4. And so that's going to be the equation of my line. All right, these next couple are just like, hey, find me an equation of the line. And so what I think I'm going to do, looks to me like this parallel to this through a point is really saying, okay, if it's parallel to this line, parallel lines have equal slopes. So I know that the slope is going to also equal 2 if the slope of this first one is 2. Oops. I know they have the same slope, and it goes through the point. Well, I should probably use point slope form. Okay, so point slope form is y minus the y-coordinate of the point we know is equal to the slope times x minus the x-coordinate of the point we know. If it's got -2, then I'll replace that with -2, so y minus -2 would be y plus 2. Nope, that was the x-coordinate. Y minus 1 is going to be m times x minus -2. That'll be plus 2 there. Okay, and well, we know that m is 2. Okay, so that's going to be equivalent to this. This probably wasn't the fastest way. I'm going to distribute these and add the 1 across. And so I got 2x plus 5. There it is. I bet there was a better way. I think we probably should have, if you were doing this on a test, you probably should have started with, oh, okay, well, I know the slope's 2, so I'm going to eliminate these. Okay, those would be lines that are perpendicular to the given line. And then passes through the point -2, 1. Well, you should just test and see, if I plug in x equals -2 to the equation in answer choice A, I'm going to get y equals -3, which is not the same as 1. So that's another reason why it's C. And if we find the equation of the line between the points 4, 3, and -1, -2, I'm probably going to start by computing the slope using the old-fashioned rise over run formula. So y2 minus y1 over x2 minus x1. And I've got -5 over -5. That's going to be 1. Okay, so I'm looking for a line with slope 1. I'm only seeing one of them, and there we go. And these two, okay, we're going to start by writing some things in interval notation. Okay, so from 3 to 7, okay, we're just going to write that with 3 comma 7. Now, if we're including 7, then we're going to use a square bracket to represent that. And if we are not including 3, because of that strict, 3 is less than x inequality, we're going to use a parenthesis there. Okay, and then for b, I think there's a third one, yeah. For b, this is looking like x is greater than -1. Okay, so we're starting at -1, but it looks like we're including -1. And then we're just going forward without stopping, right? We're going to go all the way to the right. So that's all the way towards positive infinity. But we can never equal positive infinity because infinity is not a real number. So we're just going to say -1 to infinity, including -1, not including infinity. And then x less than 0. Okay, well, that would just be, if I was going to draw you a picture of that, that would be, okay, that's going to start from -infinity and go all the way up to 0. Now, we're not going to include 0 because that's an open circle, and we're not going to, or strictly less than 0, and we're not going to include -infinity because it's not a real number. Then for this other one here, which of the following gives all values of x that satisfy the inequality? We're just going to solve this like we did in the first unit. We're going to just kind of be fair to all three sides of the inequality. So I'm going to try to get rid of that denominator of 3 just by multiplying all three sides by +3. And that won't impact the direction that the inequality is facing or anything. Okay, then I'll add 1 to all three sides to try to solve for x. So -3 plus 1 and 3 plus 1. 3 plus 1 is not 3, it's going to be 4. Okay, so -2 to 4, and then it's in interval notation, so I'm going to have to say, all right, I'm going to include 2, but not include 4. So that's going to be, oh, that was a -2, and that's going to be C there. All right, it looks like that was, yeah, that was all for Unit 1. Unit 2 is all about solving systems of equations, lots of substitution, lots of elimination, a little bit of inequalities, like graphing those inequalities or shading with the dotted line or the solid line. So which of these is the solution to this pair of linear equations? Oh, I remember this one. I almost got tricked by this one. So you just got to be careful with this one. Notice that they put the y on the left in the first equation. So the first thing I'm going to do is rewrite this. -2x plus 5y equals 6 against 3x minus 2y equals 13. Now, you could work to eliminate y. Me personally, I'm going to work to eliminate x. So I'm going to take the first equation and multiply it by 3, and the bottom equation and multiply it by 2, so that I have -6x and +6x. So I'm taking the top equation and multiplying everything by 3. And then I'm going to take the bottom equation and multiply everything by 2. I'm going to add all this stuff together, and I'm going to get 11y equals 26, and 10 would be 36. 36 and 8 would be 44. So I know that y is going to be 44 divided by 11, which is 4, and that's going to be enough for me to determine that the answer needs to be C. All right, 202 is like a read the situation and write out a system. And this is a lot. And that's why I didn't put it on the real exams, because it's just like a lot to read through. And the one that I did, but I mean, there's one very similar to this. That's a 3x3 system that you have to, turn into a. You just have to turn the English into algebra and not necessarily solve. But I think what I'm going to do, I'm just going to start with some highlightering. Okay, a box of 5 of each type of truffle costs $41.25. Okay, so I'm going to say 5 of each is $41.25, and that's going to allow me to knock off a couple of answer choices, right? It didn't say it was going to cost 5 times $41.25, It just said it was going to cost 41.25. So I'm seeing that in B and C. D, that minus 5C, minus 5N. I don't know where we would get minuses here. So I'm going to eliminate that one also. Okay, B and C have the same second equation, so I'm not even going to look at that sentence that's talking about 6875. I'm going to move on straight to the third equation. And that third equation is going to come from a box with only 24 truffles evenly divided between solid chocolate and chocolate truffles with nuts. That's 66. But it's evenly divided between just two, right? Solid and the ones with nuts. So that's going to be right here. And that's why I'm going to be choosing answer choice C. Yeah. In B, that was assuming 8 of each, but they didn't say anything about the, what is C? Cream center. No, nobody said anything about cream center in that equation I highlighted in gray. So that would be why it's answer choice C. I think, yeah, there's one more on this page. So which of the following points does not belong in the solution set of the system of linear equalities below, inequalities below? Oh, so on this one, I remember when I was working this one the first time, I started to make a, I started to like, make a plot and, or like graph the system, but then I realized that was not going to be necessary because, you kind of look at the most basic looking equation. Y is greater than negative 3. And y is greater than negative 3 for all three of these. But negative 3 itself is not greater than negative 3. It's equal. So I know that this is going to be the one that is not belonging in the solution equalities. And I know it doesn't fit all three because I can see it doesn't fit the one that I highlighted in yellow. So that's all I've got to say about that particular example. I guess that's all for that page. And then the next one is like, which one's going to represent the system? And this is the one that I remember I did not do correctly the first time. So, and I know what the right answer is supposed to be, and I'm concerned because the answer key I'm looking at, I thought I updated it, got my wrong answer out of there, but I'm still seeing the wrong answer on there. So I'm going to check and make sure that the one I posted to my course calendar is correct. All right, so I'm going to start with this blue line here. This is dotted, and it's got a y-intercept of -2 and an x-intercept of +3. So the line itself would be, it looks like 2x minus 3y equals 6 would work. Yeah. Okay. It's going to be the equation of the line in blue. But unfortunately, this is where I got tricked, was the direction. This is where y is greater, right? But if y was going to be greater, if we were going to solve for this thing, I need it to go negative there because of, if I'm going to solve for y, I'm going to either add the 3y over to the right side, and that would be where y is greater, or I'd be eventually dividing by -3, which would flip the direction of the inequality. Either way, that will be this inequality on the left in blue will be equivalent to y is greater than 2/3 of x minus 2. Regardless of how you're going to solve it. And since I need that to be 2x minus 3y less than 6, I know it's going to be answer choice B. Okay, so that one was a little tricky. I'll admit, I got tricked on this one the first time I worked it. Right, then 205, this one might be a little out of bounds for us. This is not exactly a linear system, but I thought it was good on a kind of on a setup level, so I included it. So if the area of this patio is no more than 400 square feet, and we know we can find the area of the patio by multiplying length times width. So I'm going to say L times W, no more than, means it could be equal to, so that's going to be less than or equal to 400 square feet. So I'm looking for L times W is less than or equal to 400. So I'm eliminating these two answer choices. And then the total length of the three sides of this fence is no more than 60. Okay, so they're talking about these things that I'm coloring in blue. So that looks like two W's plus an L. They said no more than 60. Well, that'd be less than or equal to again. And so I'm looking for that. 2W plus L, that's going to be answer choice A. Okay, now the next one, 206. This one's pretty big, and I'm having trouble fitting it on my shot. So I'm just gonna kind of work it, and then we'll reconcile with the answer choices at the end. So a system of linear inequalities has a solution set that forms a square when graphed on the coordinate plane. The lines that will form a part of this system of Okay, so basically the first three lines are graphed for me and also given to you down below. We just need to make this a square. So, if it's got x-intercepts of -3 and 3 and y-intercepts of -3 and 3, say it stands to reason that we need to go through here and, plot this line that I've got in red. And that will give us a square. And I feel like the more you think about why it's a square, the less obvious it is. Just look at it, right? Now it's a square. Okay. And then this will be my solution region here. It's the prettiest of her, but okay. So what we need is an equation for the red line, or really an inequality for the red line. So we'll start with an equation and slope and intercept. Y equals, the slope is looking like 1 to me, so 1x plus the y-intercept is 3. Okay. But if it's shaded, like if the shading is below the line and it's a solid line, that'll be where y is less than or equal to x plus 3. So that's what I'm going to be looking for in my answer choices. So I'm going to zoom out. Okay, so yeah, this inequality here should be showing up, y less than or equal to x plus 3. And yeah, there it is. Okay, so that's why that one would be answer choice B. Okay, what else we got? Okay, we got two more on this page. All right, which of the following best describes the graph of the system of equations shown below? The lines are parallel, the same, intersect but not perpendicular. Perpendicular. Okay, so I think that we should be able to at least start by finding the slope of each of them. I think that would probably, if we saw that the slopes were the same, I guess we'd have it down to A and B, but they're not going to be. They just look like they're going to be. All right, so let's just solve for y out of each of these equations. So I'm going to add 14y to both sides, so 6x equals 14y minus 28. And I might add 28 to both sides to try to solve for y, and then I'm going to divide everything by 4. So 6/4 of x plus 28 divided by 4 is 7. And I'll do the same thing over here. I'm going to start solving for y. So 3y equals 7x minus 14. And y is going to equal... Wait a second. Oh, yeah. I definitely did something wrong. I copied down wrong. That was 14. So it's 6/14 is the first slope. Pardon me. Okay, I'm glad I caught that in time. So y is equal to 7/3 x minus 14/3. Okay, so yeah, my two slopes are here and there. It's actually, I wouldn't have even caught it. I would have still gotten the right answer if I'd had 6/4, but it wouldn't have, the wrong answers wouldn't have been nearly as appealing. And if I'd had this. Okay, so 6/14 and 7/3. So slope 1, I might simplify 6/14 into 3/7. Right, if one of these was negative, then they'd be perpendicular. But since they're both positive, two lines with positive slopes, they can't be perpendicular. Just think about it. They've got to intersect at an acute angle. So I'm going to say that these lines intersect, but they're not perpendicular. Then number 208, this is, okay, had to have one of these on here because this was something that, we spent a lot of time practicing and took a lot of time and energy to solve these 3x3 systems, so we're going to do one right here. And I think my strategy is I'm going to use this negative y to kind of clear out basically I want to eliminate y. So I'm going to, first of all, I'm going to get a thicker pen. Hopefully this isn't too thick, but I'm going to take 3 of equation 1. I'm going to, just describe that as equation 1, equation 2, and equation 3. I'm going to take 3 of equation 1, and I'm going to add that to equation 2 to eliminate y. Okay, so 3 of equation 1 would be 6x minus 3y minus 9z equals 3. And then plus 1 of equation 2 would be 4x plus 3y plus 2z equals negative 4. Okay, add those together to eliminate y. I'll get 10x minus 7z equals negative 1. Just making sure I got that right. Okay, good. Then, in an attempt to eliminate y out of equation 3, I'm going to take 2 of equation 1 and add that to equation 3. And then that'll be 4x minus 2y minus 6z equals 2. And equation 3 would be negative 3x plus 2y plus 5z equaling negative 3. We're going to add those together. We're going to get 1x minus 1z equals negative 1. If you wanted to kind of like solve this one out the rest of the way with substitution, like solve for x, you could do that, but I don't think that's going to be necessary. I think what I'm going to do is multiply the, okay, so if I'm going to call these equation 4 and equation 5, then I'm going to take equation 4 and I'm going to add negative 7 of equation 5 to eliminate the z. And I'll say, all right, so equation 4 is 10x minus 7z equaling negative 1. And negative 7 of equation 5 would be negative 7x plus 7z is equal to positive 7. And then I'm just going to add all this together, and I get 3x equals 6. That means that x is going to be equal to 2. Okay, then x minus z equals negative 1. So 2 minus z equals negative 1. That's looking to me like z is going to need to equal 3. Then I can go back to one of my original equations to find the value of y. So maybe I'll go up to here to the first one. I'll say, all right, 2x is going to be 4 minus y. Minus 3z would be minus 9. That's going to equal 1. So negative y minus 5 equals 1. I'm kind of running out of room here, but if you can see it from here, then good for you. But if you can't, then just add 5 to both sides and get negative y equals positive 6, and y is negative 6. So if I've got x equals 2, y equals negative 6, z equals 3, then my solution is 2, negative 6, 3. And there we solved a 3 by 3 system. We did. All right, unit 3, absolute value. Okay, before I even get into this, let me just remind you, like, the biggest thing I told you about in the absolute value unit. And that was that if the absolute value of x or some expression is equal to a number, and that number is not negative, then, actually, hold on, let me split that out. If the number is negative, then there's no solution. And if the number is positive, then x equals plus or minus that number. Okay, that's the big thing, is that dropping an absolute value incurs a plus minus. That's the moral of the unit. So when I'm asked to find the solutions to 3x plus, absolute value of 3x plus 5 equals x plus 2, okay, if the absolute value of a thing is equal to x plus 2, then that thing itself is going to be positive or negative x plus 2. But since x plus 2 is itself an algebraic expression, I'm going to probably split this into 2 different scenarios. I'm kind of having a tough time finding room for this, so I'll say 3x minus 5 is equal to the negative of x plus 2. And I'm just going to have to spill over into the next problem. That's all right. Okay, and then I'm just going to solve each of these equations individually, and I'm going to subtract an x from both sides. 2x equals negative 3, x equals negative 3 halves. And then over here, I'm going to distribute the negative and just keep solving. So I add x to both sides, maybe add 5 to both sides as well. And then x is going to be, wait, what does, something bad just happened here. Let me just, oh, I miscopied 3x plus 5. So then when I subtract 2, I'm going to get 4x equals negative 7, and x is negative 7/4. Now, when we see absolute value equals expression that has a variable in it, we do need to be careful about extraneous solutions. So I'm going to check both of these. Okay, and again, the first time I was working this, I was like, man, both of these are negative. I feel like they're both going to be extraneous solutions. But if we plug in these numbers and we add 2 right there, then we're going to see that we get both values of x make a true equation. So I'm going to say that, okay, it's negative 3 halves and negative 7/4. That's answer choice A. Just be sure to check your answer when you see, absolute value of something equals something that has x's in it, because that's where we can run into extraneous solutions. So, check your answers when solving absolute value equations. Another moral from that unit. So, which equation represents the graph shown? All right. Now, there was a few things. The x-coordinate of the vertex is where we're taking the absolute value of 0. So if I plug in x equals 3, that needs to give me somewhere taking the absolute value of 0, because on the regular y equals absolute value of x graph, that sharp corner happens at 0 because that's where the behavior of absolute value changes suddenly. It goes from taking a negative number and making it positive to taking a positive number and not doing anything with it. Okay, because we know what absolute value does. We've known that for a while. So I need to be able to plug in x equals 3 and take the absolute value of 0, which is going to knock off answer choice A and D. Okay, so I've got these two left. And then from there, you could do something like, I don't know, plug in the point x equals 2 and y equals 0 and make sure that that works. But I think maybe a different thing that you could do would be to think about the slopes of these lines. Okay, so I went down by 2 when I went over by 1. So this line segment has a slope negative 2. And then over here, I'm going up by 2 when I go over by 1. Okay, so that's slope is positive 2 here. Okay, so when I'm seeing those slopes, okay, that 2 right there is representing the slopes, and so I know that's going to be answer choice C. Okay, all of those minus 2's didn't really do anything because that's just giving me the y-coordinate of the vertex, and so I'm going to eliminate any answer choices based on that. That's how I would recommend doing that, starting with a vertex and then thinking about the slopes. Right, and the next couple is just like more solving, okay, one equation, one inequality. And so with both of these, we start by just isolating the absolute value. So with this, I need to get, on 303, I need to get rid of that plus 6. So I'm going to subtract 6 from both sides of that equation. I'll get the absolute value of x plus 7 equals 9 minus 6, which is 3. And if the absolute value of something equals 3, then that thing is plus or minus 3. Now, I usually split this out into two separate equations, but since it's just a number, I think that y'all can handle this. So x is equal to negative 7 plus or minus 3. Okay, so it would be negative 7 plus 3 is negative 4. Negative 7 minus 3, that's negative 10. So negative 4 and negative 10 is what I'm looking for. Okay. And if you're concerned about the big negative numbers, just run them through the equation and make sure you get a true statement. And you're going to get a true statement for both x equals negative 4 and x equals negative 10. 304, okay, this is an inequality, so we're going to approach it more or less the same way. We're going to get the absolute value isolated. Okay, it already is. And then we're going to just kind of think about numbers. It was what I recommended you do. Okay, so where's the absolute value of a number less than or equal to 7? The absolute value of a number less than or equal to 7. Well, that would be between negative 7 and 7. Now, the absolute value is equal to 7 at these 2 points. And then the absolute value is less in between them. So I'm going to say that this thing I'm taking the absolute value of, is between negative 7 and 7. And the thing that I was taking the absolute value of was m minus 3. And so we're going to solve this inequality by adding 3 to all three sides. So that would be negative 4 to m to 10. Oh, and, okay, again, interval notation. Okay, it's going to go from 4 to 10, and because we're including both 4 and 10, they will both be square brackets. Okay, this next one, oh yeah, I like this one. Okay, so the graph of y equals the absolute value of x plus 4 plus 3 is shown below. If the 4 in the equation were replaced by a 5, what would happen to the graph? Okay, so we know that the x plus 4 really means that if I plug in x equals negative 4, I'm going to have a vertex. Okay, so vertex where x equals negative 4, because we know we're encountering a vertex when we're taking the absolute value of 0. And then, well, if I was to switch that to a 5, I'd have a vertex where x is equal to negative 5. So just kind of write that out. Okay. It's going to have a vertex where x equals negative 5. But otherwise, we haven't changed it. We haven't changed the slopes. We haven't multiplied it by anything. We haven't moved the y coordinate of the vertex around. We haven't changed that 3 on the outside. So I really just think it would just kind of look like this, that kind of a V, which is going to be 1 unit to the left of the other one. So it's okay, it moved to the left. 306 is looking like another inequality. So again, we're going to start by isolating the inequality. Okay, it's already isolated. Then I'm going to think about where is the absolute value of a number greater than or equal to 4? Well, definitely where it's bigger than 4. But also where that number is more negative than negative 4. And so I'm just going to say, okay, 2x plus 6 is either less than or equal to negative 4 from that region, or 2x plus 6 is greater than positive 4. Or I guess equal to. And then I'm just going to solve each of these inequalities separately. No, 4 minus 6 is not going to be 2. That's going to be negative 2, x greater than or equal to negative 1. All right, so I'm looking for one where we're going greater than or equal to negative 1, but also having less than or equal to negative 5. Oh, yeah, that's B right there. No, I didn't even have the inequalities there. Yeah, there we go. It's going to be B. It's, hold on, let me make sure. 306, that's B. Yeah, okay. I'm pretty sure somebody in my class would have caught that if I'd said the wrong number. Okay, now this one. 2 minus the absolute value of 3x plus 4 equals 5. Oh, that's easy enough. I'm just going to say that one has no solution, because I can see. Because I'm thinking about the absolute value always like as its own thing unto itself. So if I'm taking 2 and I'm subtracting something and getting 5, that means that that absolute value of 3x plus 4, that has to be the negative 3, right? Because I know that 2 minus negative 3 is 5. But absolute value equals a negative number. That's not going to happen. You take the absolute value of a number, and it's going to come back either 0 if you've taken the absolute value of 0, or it's going to come back positive if you've taken the absolute value of anything else besides 0. So, yeah, that's why I'm thinking no solution. It's because you get absolute value equals a negative number. And you would have gotten that if you had subtracted 2 from both sides and then divided by negative 1. You'd have ended up with absolute value 3x plus 4 equals negative 3. I was just like kind of looking at it from a farther back point of view. Right, now I'm going to move on to Unit 4, which is all about quadratic. And this was a unit that we kind of had a tough time with, but we spent a lot of time on it, and there's going to be a lot of questions on the practice exam about quadratic, and there's going to be a lot of questions on the real exam about quadratic. So, make sure that we're good on these. So the value or values of c that would make x squared minus 16x plus c a perfect square, getting at the idea of completing the square. So what we did when we completed the square was we took the number that was attached to the x, this negative 16, and we divided it in half and then squared it. And that was the number that we added to make sure it was going to be a perfect square. So if I took negative 16 and divided it in half, that would be negative 8. And if I squared negative 8, that would be positive 64. So I'm going to say it's just 64. But you might be looking at answer choice G and being like, oh, plus or minus 64, that looks pretty appealing too. But what I would say about that is that if you have x squared minus 16x minus 64, you're not going to be able to factor that into two of the same factor, which is what it means to be a perfect square. I don't even know if you're going to be able to factor that at all. Find two numbers that multiply to negative 64 while adding to negative 16. I sure can't think of any right now, because negative 8 would not work. Okay, those multiply to positive 64. Okay, well, I think that's all I've got to say about that. And then which expression is a perfect square trinomial? It's kind of a different way of asking the same question. Which one, if I factored it, would come back with two identical factors? That's going to be j, because this is equal to x minus 2 times x minus 2. If I'm thinking about two numbers that multiply to positive 4 while adding to negative 4, that'd be negative 2 and negative 2. So since I can write that polynomial as the square of a binomial, that means it's a perfect square trinomial. Okay, now on 403, what are the vertex and axis of symmetry for the parabola? Okay, we can do this. I just need to remind you that the formula for the x coordinate of the vertex is x equals negative b over 2a, where we have, a is the coefficient of x squared, b is the coefficient of x, and c is the coefficient that doesn't have any x's attached to it at all in a quadratic equation. So I'm looking for the vertex has x coordinate, x equals negative 16 over 2 times 1. That's going to be 8. Okay, so I'm ridding myself of g and h, because those are saying x equals negative 8. And now really the only difference between f and j is the y coordinate of the vertex. And, there's all sorts of ways you could go. Me personally, I'm not very good with negative 16 times 8. I mean, I could figure it out, but that's a place where I would potentially make errors. So one thing that we could do, we could use synthetic substitution here. So, 1x squared negative 16x and positive 63, I could just, copy the coefficients. And if I wanted to find the value of y when x was 8, I could just run 8 through synthetic substitution. And that's where I'm getting y equals negative 1 there. And let me just make sure that's what I got the first time. Yeah, I got j. Okay, so that's, 8 and negative 1, that's answer choice j. Okay, but you could have just, if you're good with 8 squared minus 16 times 8 plus 63, then, go ahead and do that. But that's a place where I might make an error, so I'm just going to try to avoid that if at all possible. On 404, if a rectangular poster has an area of this many square units, which of the following could describe the dimensions of the poster? This is just a fancy way of saying, hey, factor this thing. So I can't divide the 2 out of everything because 2 doesn't divide negative 9. So I'm going to go and I'm going to say, all right, with 2x squared minus 9x plus 10, I'm going to try to factor this by splitting up the middle term. I'm looking for two numbers that multiply to 2 times 10, right? We take the first number, the a and the c, and we multiply them. Okay, so m times n is 20, and then those two numbers that I'm going to find that I'm going to split negative 9x up into, they need to add up to negative 9, because that's what I'm doing with it. I'm getting rid of the negative 9x. I'm figuring out how I can split those up. So, it's going to be negative 5 and negative 4. Okay, yeah, because negative 5 times negative 4 is positive 20, and I add them together, I get negative 9. So 2x squared minus 4x minus 5x plus 10. And then I group and factor what's common to the first two at 2 and 1 power of x. And that would multiply by x minus 2. And then the second, I've got that 5, but in order to get an x minus 2, I would need to factor out a negative 5. So negative 5 times x minus 2. Take a second to check and make sure you factored right. And then we'll factor out the x minus 2. We'll be left with 2x minus 5. And that's answer choice C. Okay, so it's good that we did one of those where we're factoring where the leading coefficient wasn't 1. Expect to do that, not a whole bunch of times on the semester exam, but you should expect to do it once, right? 405. Yeah, okay, I know where I got this one from. This one was from, only for a couple of years. They had an EOC for Algebra 2, and they published all the problems, so I just went in and stole all of them. And So which inequality describes the value of a if this equation models the height of the section of the roller coaster shown in the figure? And really all is, okay, the roller coaster is in the shape of a parabola. All I can see is that it's opening upward, which means that the leading coefficient needs to be positive. Okay, if it opened down, we would have said that a was negative. To say it's between -1 and 0, we need more like the scale in y. Okay, that would be if the parabola was opening down and was really wide, relatively speaking. But we don't have any way of measuring this, so all we can really see is that the parabola is opening upward. So that means all we know is that c, a is positive. Okay, so I'm just gonna move on from that. Here's a graph for 406. Which function is best represented by the graph? Okay, well, it's going to be a downward-facing parabola, so a negative x squared. All four are already doing that. Okay, so what we'll need to do is, I guess, match up on the vertex. Yeah. Okay, so vertex form of a quadratic equation is y is some number times x minus h squared plus k, where h and k are the coordinates of the vertex. Okay, based on the answer choices, I just know a is going to be -1. Okay, I don't really need to worry about that. But h is going to be -1 and k will be 4. So I need like an x plus 1 plus 4. And so it really is looking like f to me. Okay, but both of these are looking kind of promising, h and j. Let's see what's wrong with these. Maybe if I factor out the negative on them, I'll be able to see. So x squared minus 4x minus 3. Looking for two factors of -3 that add to -4. Oh, you're not going to be able to do that because, like, -3 and +1. Okay, those are not going to add to -4. And, okay, that's the problem there. And I gotta think that the same thing's going to happen. Yeah, okay, same thing happening over here. It looks factorable. Plus 4x minus 3. You're not going to find any factors of -3 that add to +4. That's just not going to happen. Okay, so that's why it was f. That makes more sense to me now. All right, solve the equation 6x squared minus 10 equals 11x. Okay, well, if we're going to do this, we need to always start by setting the quadratic equation equal to 0. Because if we're going to use a quadratic formula, okay, that assumes that the equation is initially set to 0. Or if we're going to factor and use the zero product property, well, we need the equation set to 0. So that's going to be the first order of business, is subtracting 11x from both sides. I would like to divide both sides by that 6, but 6 doesn't divide -11 or -10, so I'm just going to leave it be. If you're not seeing any way to factor this, then you could hit this with a quadratic formula, but that would be pretty computationally intensive if you did b squared minus 4ac. It's going to be a pretty big square root. So I'm going to really advise you to try to factor this. Okay, so this is another one where we're factoring where the leading coefficient isn't 1. So we're looking for two numbers that are going to multiply to -60 while adding to -11. And that's going to be, oh, and if you're ever not sure, you can kind of just like look around, look at the problem. 15 and -4, or actually probably -15 and +4, so they add to -11. So that's what I'm going to do. I'm going to split up this -11 into -15 and +4. Okay, I've got that. I'm going to factor on 6x squared minus 15x. What is common to both of those? Okay, there's a 3. It's a common factor of 6 and 15, and an x. I'll be left with 2x minus 5. And then 4 and -10, those only have a factor of 2 in common, so I'd be left with a 2x and a -5. Okay, so that's a good sign. Means I'm factoring this thing right. Okay, so if I've got these two things multiplying together to equal 0, then that means one of them has to be 0, because we're not going to just multiply two numbers together, get 0, and not have one of them be 0. You can't just multiply non-zero by non-zero and get 0. So that means that either 2x minus 5 is equal to 0, So that's got me down to the correct answer, but maybe it'll be good for me to just convince myself. Maybe 3x plus 2 equals 0, 3x equals negative 2, and x is negative 2/3. Okay, so that's why it's J. I think this is a really good example for me to say that, while you can just plug in numbers and see if they satisfy the equation, make the equation true, that's not going to be the most efficient way for you to go. Square negative 2/3, multiply that by 6, get a common denominator with 10. It's going to be much slower, especially since you're not going to be allowed to use a calculator on the semester exam. I would just recommend using factoring, using the techniques that we learned in class. All right, number 408 is asking us what value of C makes the graphs the same. Now, if the graphs are going to be the same, then they should have the same equation. So what I'm going to do is I'm going to just kind of like expand this second equation here and hopefully, be able to just find the value, like that constant term, the y-intercept, and just match it up. That's what I'm going to do. So I'm going to go over here and I'm going to say, all right, y equals 2 times x minus 9 squared minus 18. I'm just going to kind of work on that. Well, x minus 9 times x minus 9, that's going to equal x squared minus 9x minus another 9x plus 81. So it's going to be x squared minus 18x plus 81. So I'm just going to say that this is 2 times x squared minus 18x plus 81 minus 18. So it's 2x squared negative 36x. Okay, so that's a good sign because we're matching up with those. So it's really just an issue of what do I have left. So that's plus 2 times 81 would be 162. And if I subtract 162 minus 18, the only one that's even close to that is 144. So let me think about that. If I had subtracted 20, I'd have 142. Yeah, so this is going to equal 2x squared negative 36x plus 144. And now I'm realizing, okay, I was going to say if you see a better way to do this problem, let me know, but I just saw what it is. Alternatively, C represents the y-intercept, right? And so what we could do is we also know that the y-intercept corresponds to the place where x is equal to 0. So we probably could have just plugged in x equals 0 right there and found the y-intercept of the equation I highlighted in yellow, and we would have gotten 144 the same way. Okay, but the work I did in red, that's good algebra, so I definitely don't regret it, and I think that would probably be the thing you would think to do first, so that's what I should probably show you how to do. Right, and on the next one, I really like this one. So this one's saying, what does the solution set f of x for f of x equals 0 appear to be? So I probably think that this equation or this problem should have come with the disclaimer y equals f of x, being like most technically correct, but I think you know what that means. So f of x equals 0, it's where y equals 0, so that's these 2 points right here. And what do the x coordinates appear to be? Halfway between 5 and 10, and halfway between 15 and 20. So that's going to be 7.5 and 17.5. Okay, so just like looking at it and solving it with our eyes, which has kind of been a big theme in this course. And then 410, what's the x value of the vertex of the graph? Okay, we already did this once, so we can do it again. We know that x at the vertex is equal to negative b over 2a, where a is negative 2, b is negative 8, and c is positive 3. So x equals negative 8 divided by 2 times negative 2, 8 divided by negative 4, that's going to be negative 2. On the next page, we've got more parabola questions. It's saying, which quadratic function opens down? Okay, well, that's going to be helpful. So if it opens downward, we can get rid of these ones with positive x squared because we know the leading coefficient would need to be negative if it's going to open down. And then x coordinate of the vertex equals 2. So maybe I'll just say, okay, x equals negative b. So that's positive 4 over 2 times negative 1. That's negative 2. So that one's out too, so I know it's going to be b. I can convince myself of that by saying the x-coordinate of the vertex is negative b is negative 4 over 2a is negative 2. That's going to be positive 2. And then if we plugged in, to make sure the y-coordinate was 5, f of 2 is going to be the negative of 2 squared, which is 4, right? Exponents before multiplication by negative 1. PEMDAS, right? So if we have negative x squared, we're going to square first and then make it negative. Plus 4 times 2 is 8, plus 1, so 9 minus 4, yes, that's 5. Okay, I'm feeling good about answer choice B there. On 412, we're going to write the equation of the graph below in vertex form. Okay. And this is something I didn't really get into for doing, but for like y equals 1x squared, if we're looking at the, actually, if we've got the vertex, and we're like on a grid here. This is not necessarily the origin, but if we have 1x squared, it'll go over 1 up 1 to start. And if we had 2x squared, it would go over 1 up 2. But this is looking like it's going over 1 up a half right there. I can't really draw on it, it's really small. So that's why I'm thinking it's going to be either C or D. And also it's kind of wide, it's not opening up narrower than usual, so it wouldn't be, wouldn't have a leading coefficient of 2. Okay, now we're going to probably think about the coordinates of the vertex, since all of these are written in vertex form. The vertex appears to be where x is negative 3 and y is negative 5. So y is going to be some number times x minus negative 3 squared plus a negative 5. And we determine that number is probably going to be a half, so I'm just looking for the one that matches up on that. That's going to be answer choice D. All right, keeping with the same theme, here we've got what's going to be the value of a? What's the leading coefficient? Well, because the parabola opens up, I'm going to get rid of both negative 3 and negative 8. And neither one of those are going to work for us because this parabola is opening up. If we look really close, we see that as we go over 1 from the vertex, we're going up 2. So I'm going to say that means that the value of a is 2. Alright, so that looks like that's it for the quadratic problems. Now we're moving on to Unit 5, the most recent unit. And this is all about our algebra rules, like adding, subtracting, multiplying, dividing polynomials, doing a little bit of factoring, stuff like that. So if a circle has radius of 6x to the 9, y to the 5 centimeters, and we can get the area of a circle with pi times radius squared, what's going to be the area of this circle in square centimeters? Okay, again, order of operations is going to matter for us. So area is equal to pi r squared. But exponents before multiplication by pi, because pi is just some number, so it's going to be pi times 6x to the 9 y to the 5 squared. Well, I could just look at that as 6x to the 9 y to the 5 again. And then I could just kind of like rearrange these things, because if I'm multiplying a bunch of things together, it doesn't really matter what order I'm multiplying them in, just as long as I'm not like multiplying and adding simultaneously, then I'd have to be careful. So what I'm going to do is I'm going to group all the numbers together, 6 times 6, x to the 9 times x to the 9, and y to the 5 times y to the 5. And so I've got pi times 36 times x to the 9 plus 9 times y to the 5 plus 5. And that's looking like answer choice B. Okay. The next one's talking about the area of a rectangle. So I'm going to draw the rectangle. Is 54x to the 9 y to the 8. The length of the rectangle is 6x to the 3 y to the 4, and that's going to be the width. So 6x to the 3 y to the 4 times the width, that's going to equal the area. I don't know if I left quite enough room for that, so I'm going to go over here and put that in, 54x to the 9 y to the 8. So if I'm going to solve for w, I'm going to divide both sides by this expression that I just highlighted in yellow. So I'm going to go over here and say w is going to equal 54 x to the 9 y to the 8 divided by 6x to the 3 y to the 4. And so it's going to be 54 divided by 6, which is 9. X to the 9 divided by x to the 3. That's where we would subtract our exponents. We would cancel off the ones that can be canceled, and I'd be left with 6 powers of x in the numerator. Do the same with y, and I'd be left with 4 powers of y in the numerator. So that's why the answer is going to be h. And then which of these expressions is equivalent to 14 over 8? Okay, so I'm going to start with that. And it looks like, well, that's going to help me with 1. So if I reduce 14 divided by 8, those are both even numbers, so I can divide them both in half. So it'd be 7 divided by 4. So that's got that one out. Then with a to the 4 divided by a to the negative 2, well, a to the negative 2 in the denominator is like an a to the 2 in the numerator, so I'm looking for an a to the 6 in the numerator, and that means it's going to have to be answer choice H, right? Because none of the rest of these have 6 powers of a in the numerator. But, we could say, okay, b to the 6 divided by b to the 3, that's going to be b to the 6 minus 3. And then we'll c to the negative 10, maybe I'll just make that a c to the 10 in the denominator, and the c to the negative 5 could become a c to the 5 in the numerator. I could, cancel some powers of c off, and I'd be left with 5 powers of c in the denominator, which is why I'm seeing that right there. Okay, so this answer choice H is really feeling good to me, so I'm just going to move on. All right, just 2 more pages. So 2x to the 3 minus 2 divided by x minus 5. I really liked this one. So if we're going to divide by something like x minus 5, we can use synthetic division, right? Because we can use synthetic division when we are dividing by a binomial that's just x plus a number or x minus a number. This one we're going to have to be careful with because of all of these missing terms between x to the 3 and negative 2. There's no x squareds, there's no x's. So I'm going to actually list this out to remind you where we're getting all these zeros from. 2x to the 3rd, no x squareds, no x's, and a negative 2. So I'm going to copy in the coefficients. And I'm going to divide by x minus 5, which is going to be... Okay, so I'm going to plug 5 over there, whatever would make that thing equal to 0. And then I drop down the first number, multiply. 2 times 5 is not 5. Okay, so I'm glad I caught that. Multiply, add. Although I think I would have probably had a bad remainder, and that would have been, cause for concern. So multiply, add. So multiply 5 times 10 is 50. Add 50 plus 0 is 50. Multiply 50 times 5 would be 250. Add, that's positive 248. So I'm looking for a positive 248 as a remainder. There it is. And that would be, all right, let's make sure that the coefficients all match. 2x squared, positive 10x, positive 50. That's great. Okay, so answer choice D. That's the winner. 505 is one that we're going to have to long divide because we're dividing by 3x minus 2. If this was just x minus 2, I'd use synthetic. Okay, but since I've got this 3x, it's going to be best for me to use long division. So I'm just going to jump in and do it. So negative 6x to the 3 minus 5x to the 2 plus 18x plus 11 divided by 3x minus 2. So I start off by saying, what do I multiply 3x by to get negative 6x cubed? I think I'd multiply it by a negative 2 to get the negative 6, and then 2 more powers of x. Okay, so that's going to eliminate answer choice B. Then I'll take the negative 2x squared and multiply it onto the 3x minus 2, and so we'll get negative 6x cubed and positive 4x squared. Then I'm going to subtract this away. I'm going to be left with, well, no x cubes. Negative 5 minus 4 is negative 9x squared. Drop down the plus 18x. Then I'm going to say to myself, what do I multiply 3x by 2 by to get, or no, pardon me, what do I multiply 3x by to get negative 9x squared? That's going to be a negative 3 and another power of x. So negative 2x squared minus 3x. Okay, so I know how this is going to go. I need to get negative 3x and plus 4. It's just a question of what's going to happen after that. So we're going to multiply negative 3x by 3x minus 2, get negative 9x squared. Negative 3x times negative 2 is plus 6x. Okay, subtract that all away. I'm going to get rid of that. I know it's not going to be b. I somehow doubt it's going to be d. I just don't expect this to divide away cleanly. But who knows? That's why we got to take it all the way to the end. Okay, so if I take negative 9 and subtract negative 9, I'm going to have no x squareds. 18 minus 6 will be 12x's plus 11. Okay, so I'm seeing where they're getting that plus 4 now. 4 times 3x is 12x. 4 times negative 2 is negative 8. I'm subtracting that away. Okay, so surprised they didn't have plus 3 as a remainder. That's what I would have done personally. But okay, so if I take 11 and I subtract negative 8, I'm going to get 19 as my remainder, and so that's why it's going to be answer choice C. And yeah, that is what we got. For 506, we're going to find the product, and this won't be too bad. This will just be trinomial by binomial, and you can do this with the box if you want, or you can just kind of like make sure you distribute the x to all three of the terms in the trinomial and the negative one. Me personally, I'm going to just do the box. But you should do whatever, you feel like is most likely to get you to the right answer. If it's the box, then you should do that. But if not, then you should do whatever technique that is that you do. Okay, so I'm going to just start combining like terms. I've got 7x to the 3, negative 6x to the 2, and that's going to be enough for me to see that it's going to be answer choice D, right? And then I'm going to reconcile with the other ones, positive 2x and negative 3. Great. Okay, yeah, answer choice D. Feeling good about that. Now on this last page, it's just, hey, here it is, factor it. Okay, so we can do that. If we see four things in a row that are factoring and we're seeing that parallelism, that ratio of 1 to 2 is the same as negative 25 to negative 50, well, we're going to be grouping and factoring. So I'm going to say, what can I, wait, is there a greatest common factor? Yes, I can factor out an x first. And that'll just kind of make it a little easier. I'll have x times x to the third, 2x squared, negative 25x, and negative 50. And also, I can eliminate answer choices A and C. That's not going to work. So then I'm going to factor what I can out of the first two, out of the second two. So I can see that x plus 2 is going to be a factor, which eliminates this. Okay, so I have x times x plus 2 times x squared minus 25, which, because I'm running out of room, I think, I don't need to write out that last step. I know that x squared minus 25 factors out into these two, x plus 5, x minus 5, because this is a difference of two squares. And it's got that factor of x plus 2 and the factor of x. So I know that that's going to be my answer. Okay. 4x squared minus 9. Okay, this is a difference of two square things because 4 and 9 are both square numbers. So 4x squared is the square of 2x. And so that's going to be 2x plus 3 times 2x minus 3, because a squared minus b squared, we can always factor that with a plus b and a minus b. Right? But we don't have anything for the sum of two squares. Okay, but I'm not going to say anything more about that because it's not a thing we do. Okay, so wait, then select an answer choice. That's B. Great, move on. All right. Now here we've got a couple of cubes, right? Sum of cubes, difference of cubes. We can do this. So in this situation, this is the cube of 3x, and this is the cube of 2. Yeah, so I've got the sum of two cubes. So what's going to happen is it's going to be 3x and 2 multiplied by, if I square 3x, I'll get 9x squared. If I multiply 3x and 2, I'll get 6x, and if I square 2, I'll get 4, right? Because it's always a to the 3 plus b to the 3. It starts off with a and b, and then a squared, ab, and b squared. And then the signs are the same as before, the opposite as before, and then this one's always positive. So same, opposite, always positive. And the same thing will happen with x to the 3 minus 1, because if I have a difference of two cubes, it's going to be equal to still a and b, and a squared, ab, and b squared. Again, SOAP. So this first sign will be the same as that sign. So same, opposite, always positive. So in this case, I'm cubing x and cubing 1. So I'll have x and 1 multiplied by, here I should split these up with something like that. X and 1 multiplied by x squared, 1x, and 1 squared. So same would be minus, opposite would be positive, and that one's always going to be positive. So here I am. Factor to sum and difference of two cubes. Then for E and F, okay, for E, I'm looking for a greatest common factor, and I'm finding one. Okay, so I'm saying, what can I factor out? Definitely a 6, but then I think I can also factor out 3 powers of x. And so what would I multiply 6x cubed by to get 6x to the 5? Well, that would be 2 powers of x minus x minus 2. And then this quadratic here inside the parentheses that I just highlighted in yellow, that's something I can factor as well. Okay, I can find two numbers that multiply to negative 2 and add to negative 1. That would be negative 2 and positive 1. Now look at it, I see none of my factors can be further factored, and so I know I'm done now. For the next one, I'm looking for a greatest common factor, but I don't see t in all three terms. I don't see 3 even number terms, so I'm not going to be able to do anything more with this. We've already done a couple of examples where the leading factoring where the leading coefficient wasn't 1, but I'll do it one more time for you. So I'm looking for two numbers that multiply to 20 while adding to negative 9. Wait, didn't we already factor this? That's a shame. Yeah, we already did this once, but it's not bad to practice on that a second time. So that it's going to be negative 5 and negative 4. So 2t squared minus 5t. Maybe I'll split up the middle term the opposite of the way I did last time, and you'll see that it works out the exact same way no matter how you split it up, just provided that you split it up into the right terms. Okay. And so then I will say, what can I factor out of 2t squared minus 5t? Well, I think just the t. And then negative 4t plus 10, I'm going to factor out a negative 2 from that. And then I'll be left with a 2t minus 5. Yeah, that was the thing to do. And then I'll factor the binomial, 2t minus 5, and I'll be left with a t and a minus 2, and that's fully factored. Okay, yeah, here we are, an hour and 7 minutes in. That was a good practice test. It was like pretty diverse, had all the stuff that we did throughout the year. The only thing that I'm just like noticing right now that I'm thinking about, hey, I didn't do that in the practice test, was focus directrix of a parabola. Okay, so if you've watched all the way to an hour and 7 minutes, I'll tell you, I did put one multiple choice question on the semester exam that was talking about focus and directrix of a parabola. And so either if you're just not worried about one problem, then you'll figure it out. But if you are, if you want to make sure that you know all the topics, then you should probably go back to the review or to your lesson notes or to the quiz or something like that. So when we studied focus and directrix, let me look that up real quick. Yeah, that was Unit 4, Lesson 3. So if you're looking for, materials to help yourself practice focus and directrix, you should be looking for 4.3. All right, that's all I got to tell you. Thanks for watching. I really hope this helped.